This is Chapter 9, Section 2, Solving Stoichiometry Problems. Hopefully you have your notes in front of you. You've been able to print them from Edmodo or my website. We're going to start talking about how we use those mole ratios we talked about last lesson to find exactly how many grams of each reactant or product are consumed or produced. So keep in mind, we look at the second bullet. The number of grams in 1 mole is just the sum of the masses of those elements. Now, I found this little triangle for us. It's kind of like the density triangle. If you are looking for atomic mass, that will tell you the number of mass in 1 moles, the number of grams in 1 moles. That's what you find on your periodic table. If you're looking for the mass of something, you move that up there. It's the number of moles times the atomic mass. Now this is what we do in our T-chart, but this might kind of clear it up in your head. And then if I'm looking for the numbers of moles of something, well, that's going to end up being my mass divided by my atomic mass, or vice versa, depending. So that's just kind of something to help clear that up just a bit. There is a video. If you click on this on just the PowerPoint, you can watch the mole to mass video, but let's keep moving. Okay, here's our first problem. If you look at the equation, you see 3 iron plus 4 water yields 4 hydrogen and 1 iron oxide. So we're going to go through and try to solve this. We need to know how many moles of iron oxide can be formed from 3.47 moles of iron. So just stick with me. I pulled this problem from somewhere else and it doesn't look exactly right, but it'll work for our purposes today. So go ahead and fill out your given, unknown, and solution. Set your T-chart up. Pause the video. Alright, so let's check. How'd you do? Your given is the 3.4 moles of iron. That's what you are starting your conversion off with. Your unknown is moles of Fe3O4. Solution, we're going from moles of iron to moles of Fe3O4. So look at that mole ratio. You have 3 moles of iron for every 1 mole of Fe3O4. We're going to need that in just a second. Set up your T-chart. You don't have to solve just yet. Just set it up. Pause the video. Okay, hopefully you set your given in the top left box. So you have 3.47 moles of iron. And then where does moles of iron have to go so it can cancel? Good. Set it up. So it should be sitting back there, or down there, sorry, 3 moles of iron for how many moles of Fe3O4? Good, set it up. And on the top, you've got 1 mole Fe3O4. Now we're going to have to cancel our units. So moles of iron cancels top and bottom, and we're left with moles Fe3O4. Now you're going to do your math. Multiply across the top, divide what's on the bottom, and solve. Now hopefully when you did your math, you got the same thing I got, 1.16 moles of Fe3O4, and I used 3 figures because I was given 3 significant figures. So get all this jotted down, pause the video if you need, and then we'll move on. Okay, so hopefully you're seeing those mole ratios are pretty important. Now this one is going to be a little bit longer, so I've got a 1-step set up at the bottom. It's actually going to be 2 steps because it's not just mole to mole, it's moles to grams. So look at your given, your unknown, and solution, and let's figure this out. Okay, so I fixed my T-chart, and hopefully you have deciphered the question. And you see that we are given 0.275 moles C6H12O6. They're asking us to find grams of CO2. So my first step is moles of my given, but I can only go to moles of CO2. Then I have to go to grams of CO2. So stay with me. This is going to take a minute, okay? Start setting it up. Work with your units first. Pause the video. Alright, so let's start this T-chart with our given. Put that up at the top corner, top left corner. Alright, now we've got to have moles of C6H12O6 on the bottom. And we're going to what? moles of CO2. Now guys, this step comes directly from the equation. So look up there. How many moles of C6H12O6 and how many moles of CO2? Look carefully, fill it out. Pause. Okay, so hopefully you can see that there's one C6H12O6 and there's 6 CO2s. So we just make sure our units are going to cancel and you get 1 mole to 6 moles, molar ratio. Alright, so good so far, or sorry, so far so good. We can cancel moles of C6H12O6 now. Now we're in moles of CO2. Now I got to get to grams of CO2, so that's going to be my next step. Set it up. Okay, so for me to get those units to cancel, for every 6 moles of CO2, I got to get to 1 mole. So we put the 1 mole on the bottom. That way we can cancel those 2 units. And I've got to get to grams on the top. How do you find grams of CO2? Good, go at it. Okay, if you haven't paused, pause so you can add. And hopefully you have added it up that there's 1 carbon and 2 oxygens, and that comes up to 44.01 grams of CO2 per mole. So you notice, again, that's a conversion factor. There's always that many grams in 1 mole. So multiply across the top, divide whatever's on bottom, and write your answer down. Alright, when you multiply all that in your calculator, 0.275 times 6 times 44.01, you should have gotten 72.6 grams of CO2. Again, I used 3 sig figs because that was what was given in my problem. Alright guys, if you had trouble, go back, go step by step again, make sure you're pausing when I stop talking. Okay guys, third word problem, or stoichiometry problem. How many moles of nitrogen are needed to produce 56.9 grams of ammonia? Say that's all you needed for whatever you were doing. How many moles of ammonia, how many counting units are needed to produce 56.9 grams of ammonia? So go ahead, set up your given. What is actually given to you with numbers and formulas? What's your unknown? What are you fine to ask? And how are we going to get there? Pause the video. Okay, hopefully you've done that, and you can see that we're given 56.9 grams of ammonia. We're looking for moles of nitrogen. We have to start with the grams of ammonia. We have to get that to moles of ammonia, and then from moles of ammonia to moles of nitrogen. So let's get started. Set it up with the top left corner with your given. So our given was 56.9 grams of NH3. Now I've got to get from grams of ammonia to moles of ammonia. Guys, that's just using your periodic table. Add it up, nitrogen and 3 hydrogen, that'll give you your grams, which when you add it is 17.04. If you need to go back and add, pause now and do that. And that's in 1 mole of ammonia. So we just put that on top. Now at this point we can go ahead and cancel our grams of ammonia. They cancel top and bottom. Good. Now we're at moles of ammonia. Now I've got to do one more step to get from moles of ammonia to moles of nitrogen. Well, how do those relate in this equation? Look at your coefficients. How many ammonia for how many nitrogen? Hopefully you see that there's 2 moles of ammonia for every 1 mole of nitrogen. Alright, so that just came from my equation when I'm going mole to mole, just from the equation. Now let's cancel our mole of ammonia units. And I'm ready to solve. So guys, when you set this up, it's 56.9 divided by whatever 17.04 times 2 is. Do you see that? So make sure you're typing this in correctly. Go ahead and solve. And hopefully you see that you get 1.67 moles of nitrogen. And I used 3 significant figures because that's what I was given in the problem. Alright, we'll move on to the last problem. And we're on our last problem. We have methane, CH4, reacting in oxygen to give you water and carbon dioxide. What type of reaction is this? Yep, anytime it reacts in air and gives you water and CO2, it's a combustion reaction. So how many grams of water will be produced if I started with 74.5 grams of methane? That's the question we're trying to answer. So set up your given, unknown, and solution. Pause the video now. Hopefully you found that the given was 74.5 grams of methane. We're going to grams of H2O. So this is why I have 4 steps total. Okay? So we have to start with our grams of CH4. We're moving to moles of CH4. We can only go grams to moles of the same thing. Moles allows us to interchange between compounds. So we'll go from moles methane, CH4, to moles water, H2O. And then in the next step, we'll go from moles of H2O to grams of water. Okay? All right, here we go. Set up with your given. Got 74.5 grams of methane, and I've got to get methane on the bottom again, and it's going to be grams. Now, anytime you're not given those grams, you find them on your periodic table. Go add carbon and 4 hydrogens. Pause the video if you need. When I added them together, 12 plus roughly 4 is 16.05 when it's all said and done. Grams of methane, and that's in 1 mole of methane. Awesome. So one step down. Now I've done my grams, and I'm at moles of methane. Now for me to get to moles of water, I look at my coefficients. For every 1 mole of methane, that goes on bottom, there are how many moles of water formed? Good. 2 moles of water formed. Now I'm at moles of water. Sweet, I'm another step down. Cancel your units. Now, every 1 mole of water, gives me 18.02 grams of water. So again, cancel units. And I'm left where I wanted to be at grams of water. Again, that grams in 1 mole comes from your periodic table. So now we're ready to solve. You're going to multiply what's on top, 74.5 times 2 times 18.02. All of that equals divided by 16.05. And pause so you can do your math. When it's all said and done, you should have 167 grams H2O. And I left it at 167, no decimal, because that's 3 sig figs. Good job, guys. Okay, so here's a little picture to kind of put all this together in your head real quick. We're not using molecules right now, so don't focus on that. But if I'm going from mass of one thing to grams or mass of another, I'm going to go from mass, I'm going to use my molar mass to get to moles, use that mole ratio, and then I'm going to use that molar mass to get to mass of the last thing. Okay? If I'm starting at moles of one thing, I'll start here, and I'll use my mole ratio to get me to moles of the other, or if I need one more step, I'll use the molar mass of that second to get to grams of the second. This is just kind of how many steps do you need to get where you want to be, so just look this over for a little bit, and hopefully it helps out. Your homework to get some practice at this is homework set 9-2. I've worked out number 1 for you, so you can click on the answer one to fill that one out. The rest needs to be finished before next class, and if you need to, you can print it from Edmodo or my website. Homework set 9-2. Good luck, guys.